Welcome to Ask and Learn.
Okay, so here we have an is equal to 4 times an minus 1 minus 4 times an minus 2 plus n plus 1 times 2 to the power of n. So we'll start with our roots characteristic equation, where we replace an with r squared, and an minus 1 will be equal to r, and then an minus 2 will be equal to 1. And these other functions of n will be equal to 0. And so we can rewrite this as r minus 2 squared is equal to 0. So if we just move everything to the left-hand side and factor, and so this means our roots are equal to 2 with multiplicity 2. So then the solution to the homogeneous portion, and we'll put a little h here to remind us that it's just part of the solution, is going to be alpha 1 times 2 to the power of n, and then add that to alpha 2, and then since it's the same root with multiplicity, we'll multiply it by n, and then by 2 to the power of n. Okay, so this is our homogeneous solution, and we move on to the particular solution. And so the particular solution is equal to n plus 1 times 2 to the power of n. Okay, so we will take our particular solution, an to the power of p, to be equal to n squared times p1 times n plus p naught times 2 to the power of n. And this is because 2 is the root of the characteristic equation with multiplicity 2. So we can rewrite this a little bit to be p1 times n cubed times 2 to the power of n plus p naught times n squared times 2 to the power of n. And this particular solution needs to satisfy our recurrence relationship. So we'll take our an is equal to 4 times an minus 1 minus 4 times an minus 2 plus n plus 1 times 2 to the power of n. And we'll put in that particular solution from the previous page. So we get p1 times n cubed times 2 to the power of n plus p naught times n squared times 2 to the power of n is equal to 4 times p1 times n minus 1 cubed times 2 to the n minus 1 plus 4 times p naught times n minus 1 squared times 2 to the power of n minus 1 minus 4 times p1 times n minus 2 cubed times 2 to the n minus 2 minus 4 times p naught times n minus 2 squared times 2 to the n minus 2 plus n plus 1 times 2 to the power of n. Okay, so we can actually pull some of the 2's out, and so what we'll end up doing is we'll get 4 times p1 times n cubed times 2 to the power of n minus 2, so we pulled 4 out. We'll do the same thing here, so we'll do plus 4 times p naught n squared times 2 to the power of n minus 2. We'll do the same thing here, so instead of a 4, we'll have an 8. Okay, and then this becomes n minus 2. We'll do the same thing here, so we'll get an 8 times p naught times n minus 1 squared times 2 to the power of n minus 2. Let's keep this one the same. 4 minus 4 p1 n minus 2 cubed times 2 to the n minus 2. We'll keep this one the same. And the last one will also modify, so that'll say plus 4 to the n minus 2. And now we can actually add and subtract them from each other, right? So this ends up equaling 4 p1 n cubed plus 4 p naught n squared being equal to 8 times p1 times n minus 1 cubed plus 8 p naught times n minus 1 squared minus 4 p1 times n minus 2 cubed minus 4 times p naught times n minus 2 squared plus 4 times n plus 1. I've run out of room, so I'll continue on the next page here. We can combine our p1s and p naughts together, so this is equal to 4 times p1 times n cubed plus 4 times p naught times n squared being equal to p1 times 8 times n minus 1 cubed minus 4 times n minus 2 cubed plus p naught times 8 times n minus 1 squared minus 4 times n minus 2 squared plus 4n plus 4. Okay, and then we can factor out what's in these brackets here. So we get that this expression on the left is then equal to p1 times 4n cubed minus 24n plus 24 plus p naught times 4n squared minus 8 plus 4n plus 4. Okay, and if we subtract what's on the left from what's on the right, we are left with 0 is equal to negative 24 p1 plus 4 times n plus 24 p1 minus 8 p naught plus 4. Okay, so what we know is that these two coefficients, what's in the brackets, have to equal 0. So this means that 0 is equal to negative 24 p1 plus 4, and 0 is equal to 24 p1 minus 8 times p0 plus 4. So if we solve this, subtract 4 from both sides, and divide by 24, we get that P1 is equal to 1/6. And for here, we can put 1/6 into P1. And what we end up with is 4 minus 8 times P naught plus 4 is equal to 0. Right, so what we end up getting from that is that P naught is equal to 1. And so we can use that to determine our particular solution. So if we put these values into our particular solution, which was of the form P1 times n cubed times 2 to the power of n plus P naught times n squared times 2 to the power of n, we then get 1/6 times n cubed times 2 to the power of n plus n squared times 2 to the power of n. Okay, so now we just have to combine that with our homogeneous solution, right? So we need our an will be equal to the homogeneous portion plus the particular portion. And so from right away in the beginning, we had our homogeneous portion being alpha 1 times 2 to the power of n plus alpha 2 times n times 2 to the power of n. And we'll add the particular solution we just figured out, which is 1/6 times n cubed times 2 to the power of n plus n squared times 2 to the power of n. And if you want to take it one step further, we do have a common factor in all of these. So you could factor out the 2 to the power of n and just have that it is equal to 2 to the power of n times alpha 1 plus alpha 2n plus 1/6 n cubed plus n squared. And that is the final solution.